Makes sense, right? You're untethered and you can kind of go and roam.
Yeah.
It's actually the safety bit. So the navigation, have you ever had to kind of go and do scuba diving training where when you go, you got to go out a certain direction
Yeah.
and then it disorients you and then you got to find your way back to a single spot.
Yeah.
Now, this is going to be giant and green. Hot water to kind of keep the divers warm. Another key element to this besides that functional component is safety.
Best way to kind of describe Deep, as many navies across the world, they view us as their SpaceX. The ocean covers 72% of the Earth. Now, we're not two-dimensional species, we're three-dimensional species. So the ocean covers 99% of our habitable biome. It provides the primary protein for 3 billion people on this planet. It's a primary heat sink. It's a primary carbon sink. Also importantly, and this is something I've learned since my involvement with Deep a few years ago, the majority of the oxygen that you and I are breathing right now, that the viewers are breathing, comes from the ocean, not the rainforest. Now, you see something that's so critically important, but there's this massive knowledge gap. We've only mapped about 20-25% of the ocean. We've only discovered, we estimate, or other agencies estimate, about 15-20% of the species that live there. That is an unreasonable gap. What we're doing here at Deep is we're trying to address those challenges, address that gap by applying our technologies and our procedures to help bring humans back into the ocean. Our mission is to make humans aquatic. We want people to become aware and understand how critical the ocean is. We don't want it to just be out of sight and out of mind. We want to kind of alter people's neurons. We want them at a very young age to recognize that the ocean is something to better understand, to protect, and to genuinely love. What we're doing, we're bringing it down, is we're creating more pressure inside of the habitat. So as you go down, you put more air into the habitat and you increase that pressure. So what you have then is you have, once you're down at depth, what allows you to use that moon pool is what we call ambient. Same pressure on the outside, same pressure on the inside. And then that allows the humans to adapt to that type of environment and then ultimately be able to use the Sentinel or the Vanguard in the way that it's intended to. One where you kind of create that fluid exchange between the outside world and then your inside space in the habitat. What our habitats really unlock is they create that connectivity with the seabed. So anyone that would go into our Vanguard or our Sentinel, they'll recognize that there's a moon pool. So if you were standing in there, you'd see a section of the floor, which is just water. And what that allows you to do is to go and dive out and experience and do your work, your research, your reconnaissance, whatever it might be, and then bring that back in and do that work and continue your work in a laboratory that's contained within the habitat. So Sentinel, what we wanted to do is give people that kind of comfort to be able down there. Now, it's not going to be 4 seasons, but it's something where we want researchers to want to go back and live there. So they're large. So they're 20 meters in length. They're 6 meters in diameter. So if anyone's flown on a Boeing 777, the dual aisle aircraft that goes long haul, if you roughly cut that in 1/3, that's the size of the habitat that we're talking about. It's split level. You have your accommodations on top. Good quality sleep is a very important thing, particularly when you want to do good quality work. You've got your dry labs or your wet labs. So how do we get there? Well, the pathway to that is actually Vanguard, which we will be unveiling at the end of this month. So when we're set out to deliver Sentinel, that whole pathway starts with major engineering practices that go through in terms of being able to kind of design and engineer that habitat. But that's on the exterior. A very critical component is all the interior systems, the stuff that keeps us alive, so the environmental and life conditioning systems. And that's about how you handle water, how you handle your air, the environment and the temperature and so forth, electricity. And a lot of that needed to be developed. And in that pathway, said, okay, well, you don't just go and build the really big thing and do all of that. You do that in a smaller fashion, and you make sure that you've got the right technology, the right innovations, because a lot of this is not necessarily off the shelf. And it's not going to house 6 people. It's going to house 3 to 4 people. It's not going to go to 200 meters. It's going to go to 100 meters. And because that's smaller feature, it's going to be more redeployable, which again is a very key element for Sentinel as well as for Vanguard. So this is 3D printing with metal, large robots that are working at the same time. And we poured a considerable amount of resources and talent and brain cells into building what is today the largest by volume footprint of these robots in Europe. So as we speak right now, Vanguard is being assembled. So we have all the components put together. Now you got to start to screw the pieces together. And that will be deployed by the end of this year. So again, we're doing it. People will be getting wet and using our habitats in short order.